once again, welcome to the Edge Compute workshop. This is AI Saturday. AI Saturday is a non-governmental organization. So I've been doing this thing since 2018 or so. And that's actually been a big one for all of us because it all started with the initiative of, we need to create awareness of how to use AI, like how to use AI to build interesting products, how to just understand what is happening. It all started with curiosity, right? And thanks to Teju and Femi, Aziz, they are still the co-founders of AI Saturday, right? So they all both came together, came up with the idea, and ever since then, it has just been, a lot of things have been happening. We've had like students coming to the program. It's actually free, coming to the program, some for masters, some for PhD, some are working in some in Canada, some in different parts of the world. So yeah, Saturday has been, for me, that's a personal impact on me. And anytime there is need to, give back in quotes, we do that. So, and the main forum of giving back is usually through what we are doing now, right? So, and for those who are not familiar with AI Saturday, once again, AI Saturday is a non-governmental, is an NGO, right? And is an educational community building. What should I word am I going to put in the front? Platform. It's not a platform. So, and initially, I think this is like our first physical meetup since COVID. Everything has been virtual, right? And the aspects to it being virtual means that we have like greater reach. But that aside, this is Edge Compute workshop. So the workshop is like over 1 year in the making. Like we have been struggling to have this workshop. Initially, we reached out to Nvidia, then some things happened, then I think we're just busy. Then this year, we're like, you know what, we have to just do this workshop this year and let's see how it goes. So once again, the workshop is Edge Compute workshop. Then a bit about myself. So my name is Igwegbe George, and I am actually currently the ambassador to Edinburgh, which is one of the sponsors for this program. I'm a machine learning engineer at Ankari Labs, and I've done like a couple of different stuff from IoT to computer vision. I'm currently interested in deploying models on edge devices and video analytics. And other things, University of Lagos graduate, mechanical engineering, TensorFlow developer, experts. And there's one stuff I'll probably talk about, this tiny ML paper and projects. It's still related to what we are doing. I'm going to talk about that. And like for someone actually asked about Tiny ML Nigeria. There's also an organization called Tiny ML Nigeria. And it's just see this workshop, let's just see the organization as an organization that is focused on deploying machine learning model on edge device. So that's what the Tiny ML is all about. So I'll talk about that later. So that's a bit about myself. I don't really like talking about myself, but that's all. So let's talk about what this workshop is all about. So in this workshop, you are going to learn a lot of things. So first of all, I think you all know what the Jetson device is all about. Like I think you guys have seen the Jetson device, but you have not seen the actual device. So you get to like train and deploy model on Jetson Nano, Linux basic commands. So when we are trying to like onboard people, is it onboard? No, we are trying to like get people to enroll for this program. We had like a couple of requirements, right? Linux, Python, blah, blah, blah. So for me, I was the one that selected all of you. The Python and Linux are like important, like they are vital. They are actually crucial. So I am not going to negotiate with that because I don't want a situation whereby someone will be in the class and they are struggling with that, right? And when I mean Python, I'm not talking about like heavy Python and like you know how to assign variable, you can recognize function, while loop, for loop, like basic stuff, right? Then for the Linux, just how to use any of the Linux distro, be it Ubuntu, Raspbian, Mint, Fedora, whatever it is, right? Then another thing is you get to work with Linux, right? Because yeah, we already talked about that. Then Jupyter notebooks like Jupyter Lab. This is not like art constraint, but you also get to learn about that. Docker, yeah, is another big player. The DLI program is actually on the Docker container, right? So I'll talk about Docker. Then other things you probably get to learn about is SSH slash BNC. So this is how you're going to communicate with the device, right? You're going to SSH into the device, or you're going to use BNC, whatever approach you want to go with, it's up to you. Then of course, I expect you all to know how to use GitHub. Worst case scenario, know how to clone a project from GitHub. Not really that complicated. But then if you have issues, we'll always resolve them. So going back to it, another thing is we're going to train and deploy model on edge devices using Edge Impulse. I'm going to talk about Edge Impulse today. Then finally, using the above all together. So we're going to learn how to use all of them all together. A bit so one of them here and here, but we're going to learn how to use all of them all together. So we're going to talk about, for this week, we're just going to focus more on intro and setting up. So we're going to do the intro here, then the setting up, do it at the other side. So the title of this workshop is called Edge Computing. That's the theme of the workshop, right? And the question is going to be, what exactly are these edge devices? Like when it says an edge device, what exactly does it mean? So edge device for me has like different meanings, right? For me, I see edge device as a device that enables you to communicate to the bigger space, like the internet, right? That's how I actually see edge device. And now I also see edge device from the point of view of computation, right? Your mobile phone is an edge device. Your wristwatch, your smartwatch are actually edge devices. In some parts of the world, we have like San Francisco and Boston, we have self-driving cars. And these self-driving cars apparently are actually edge devices, right? So in general, what we can say is that an edge device or edge device is a piece of equipment that serves to transmit data between the local network and the cloud. So going back to the phone, your phone is an edge device. Let me give you an instance. So the popular Google, Hello Google or Hello Siri model that is deployed on the phone, when you say Hello Siri, what happens is that command, that Hello Siri command is going to spin up like a service. It's going to activate like a service. So whatever you say after that will now be transmitted to the cloud. Hello Siri will work whether there's internet or not. True of us. But then if there is internet, what happens? It gives you a response, right? Okay, hello Siri, what is the longest bridge in Africa? It's going to work to tell you that, okay, the longest bridge in Africa is so and so thing. But if there is no internet, it will still respond to tell you that there is no internet, you understand? So at that level, that is actually an edge device. The mobile phone is actually an edge device. What does it do? It transmits data from the local network to the cloud. So that's how I see edge device, right? And another thing is an edge device works by being near to the source of the data it manages. So just like the mobile phone, right? It's closer, the mobile phone is close to the source. What's the source of data? You are the source of data. we generate a lot of data. Our mobile phone, what makes the mobile phone actually interesting is that it has a lot of sensors. So you have like accelerometer on your mobile phone. I think you have gyroscope on your mobile phone. You have the microphone, you have the camera, you have a tons of, they have a lot of sensors. You have like a couple of temperature sensors on your mobile phone. So the mobile phone is like the perfect edge device you have around. Then for the self-driving cars, they have their own sensors. You have like the ultrasonic sensor, you have LiDAR, radar, IR sensor, right? Some of them comes with sonic sensor, I believe, right? So looking at it, they need these sensors to do what? To perceive their environment, to perceive the road, to know is this a lane or not, is this human or not, right? So without those sensors, they are basically useless, right? So once they capture that data, they tend to transmit it. But before they capture that data, they need to process that data. So that leads us to the next part of what an edge device is. So an edge device or edge devices are devices whose compute, memory, energy resources are constrained, cannot be easily increased or decreased. So your mobile phone, let's go back to the mobile phone. I want to bump my mobile phone to, I don't know how many gig RAM we have mobile phone. I think it's like 60, we're up to 6 gig RAM, right? So I want to bump 12, yeah, even 12 gig now. Wow. So I want to bump it up to 20 gig. Can you? You're getting a new one. Yeah. So that's like the constraint for edge devices. So you can't easily increase the RAM. You can't easily swap the sensor. I want to use a better accelerometer, or if I want to change my camera, you can't do that. That's the form factor. So look at it from the point of view of computation and communication. That's how I expect you all to look at it. So the Jetson Nano we are going to use today is actually an edge device. I think I've mentioned that, right? And the power consumption is about 10 watts, right? Then they are still in the same space of edge devices. You have things like in the tiny ML region for devices or for edge devices that are less than 1 watts. We regard that region as tiny ML edge devices. Like they don't consume much power. But for this consumes about, the Jetson Nano consumes about 10 watts, right? Then for the self-driving car is about 100 watts. So you can see when we talk about edge devices, it's actually a big space. So the idea is that I want you guys to look at things around you. Does this thing look at it from, is this an edge device or not? Your laptop is an edge device. It's going to work without the internet. You can do a lot of computation with it without the internet, right? With internet, works better. Which other thing again? Your wristwatch, the smart wristwatch is an edge device. Any other edge device you can identify around us?
Cameras.
Digital cameras, CCTV cameras is a sensor, right? But with the NDR, it is an edge device. Yeah. So that's that for edge device. I hope you guys are all familiar with what edge devices is, right? So let's move to the next one. So we've talked about edge device, we've talked about computation, talked about communication, right? Then the question is, what is edge computing? Like, what do you mean by edge computing? Like, so when you are doing those communication and computation, that all those processes, like you are processing data that are closer to the source, that process is actually edge computing. That is what it is. So the communication part, the computational part, that process is actually edge computing. So it refers to the computation being performed as close to the data source as possible instead of far off remote location. So let's go back to machine learning, right? Or let's just still stick with machine learning. Mostly, your popular ChatGPT, can it work without the internet? No. So you need the internet to do that. So you're not doing edge computing, you're doing cloud computing, right? So that's not edge computing. Your mobile phone, is it going to work without the internet?
Yeah.
Some pictures can work without the internet. So that is edge computing, right? Then, which other thing again? There are a couple of sensors that are like all these weather sensors, right? When you see a proper micro weather station, they have a couple of sensors. They work without the internet. They only get to transmit their data when required, right? So look at it from that space. Another interesting thing about the edge, the IoT space is by estimates, about 25 billion devices are already connected to the internet by 2020. That's like 3 years ago. So we have more now. And it's expected that about 3.9 to 11 trillion dollars, the economic impact of IoT per annual till like 2025, right? So you can see that the space is going to be a big one. And it makes sense for you to start thinking about what can I do with this? Like, what exactly can I do? And let's be realistic. Some solutions are not supposed to be cloud computing. Some solutions are actually meant to be on device. So another assumption, I expect you all to be familiar with AI. But then if you're not familiar with AI, it's still fine. So the question is, AI has been a buzzword lately, and like thanks to what is happening with ChatGPT, Google Bard, and the rest. And the main reason why AI is actually a big deal is because it's solving problems. I don't like comparing AI with crypto. But you guys all know what happened to crypto last year.
Yeah.
After so much buzz, like apparently all crypto bros are now AI experts. So after so much buzz last year and 2 years ago during COVID, like they just went down quietly. We know why they went down quietly. I'm not saying the technology, crypto, the blockchain technology, I'm not saying that it is not a good technology. It is a good technology, but just that the idea of tying it to finance has always been centralized. There's a reason why it's centralized, right? And sometimes sometimes we tend to like separate the problem and the technology, right? And I think it's actually, you should, sometimes I don't even look at the technology, I focus more on the problem, right? So you should think about the problem rather than being overly emotionally attached to the technology. Oh, this is Web 3.0. When people throw buzzwords like that, it's fine, but what problem is it solving? Do I need Web 3.0 to send my money to you? No, we are still on Web 2.0. Apologies, like the most of the things we are doing, the most of the things you interact with is actually Web 2.0. That's the truth. So we need to acknowledge that. So, but AI is not like crypto because AI has been solving problems, right? This projector was not working today. What happened? Someone actually went on ChatGPT and was asking questions. I was surprised. I was like, really? But then it makes sense. Like it solves problems. So it solves problems. I'm not saying the crypto stuff does not. Please, once again, I'm not hating on the crypto bros. I'm not doing that. What I'm trying to compare to technology. It's sad I cannot compare apples to apples, right? But let's compare apples to oranges. AI is the big bro, right? I'm not saying crypto is the small bro, but it is. It is, right? It is what it is. So let's switch to what we are doing. So what is AI? So AI is just a branch of computer science that has to do with building intelligent systems, right? At its core, it is optimization. Like at its core, all we are doing is we are just optimizing. We're trying to like solve the problem at its core, right? And looking at it, there are like different different sections to AI. So you have something called machine learning, which is a subset of AI, right? It's a data-driven subset of AI. Then in machine learning, you have the deep learning. And the deep learning is actually inspired by the human brain, right? The neurons in the human brain. So you have something called the artificial neuron, right? And basically, what this is trying to do is trying to imitate the human brain. So we regard the neural network as a function approximator, right? They can approximate any function around us. And the truth of it is that vision, you are seeing, the way you are seeing it is a function. The way you are hearing is actually a function. Everything around us is just signals, right? So neural network has the capability to approximate these functions and signals, right? So AI has been solving a lot of problems lately, be it ChatGPT, be it the self-driving, be it what we are doing, the edge computing. It has broad impact. And the good thing is that you interact with it day to day. That's the reason why I don't want to compare it with crypto. Google Map is backed by like strictly AI. If you're using YouTube, you have like a couple of recommendation system, a recommender system at the background, right? If you're using TikTok, TikTok is just a AI-driven recommender system. If you're using Twitter, AI, like everything around you is AI. Even in your banking app, right? Fraud detection, AI. So you interact with AI applications more than any other thing. So in terms of impact, it's obvious. So that takes us to the next thing. So what is machine learning? So I think I've already mentioned that. So machine learning uses data to produce a program to perform a task. So the way we do our standard programming, the computations that we do like the standard programming. You have a task. You will break the task into modules. If and else comes in here and there, your while loop, your for loop, do your thing, right? But then the problem is not really a problem. It has always worked. Programming has always worked. That's service purpose. But then the good thing about machine learning is that you don't necessarily have to write those programs, right? You don't actually have to write those programs. How about learning from data? Why write those programs when you know you can actually learn from data, right? And mind you are dealing with edge computing. An instance is the mobile phone. We all have the mobile phone, right? So imagine writing if and else statement to know when you are active, when you are sitting down, when you are standing, when you are running. They are like different scenarios. So you're going to write a lot of if and else statements, right? But now look at it from the point of view of machine learning. I have the data. I can gather data for standing, gather data for sitting, gather data for sleeping, send that data to a model, train it, then perform inference, do inference. By analyzing the inputs coming from the sensor, it can tell if you are sitting, you are standing, you are sleeping. So it's a different kind of programming. According to Andrew Kapati, he regards that as software 2.0. Software 2.0 simply means that we are not writing, you're not explicitly writing the programs, right? You're not explicitly writing the programs. The program data is, we are writing the programs through data. Yeah, that's actually what it is. We are writing the programs through data. So instead of writing if and else statements, you gather data for different scenarios that you want to analyze. So that takes us to the next one, which is when we talked about machine learning. So the subset of machine learning is called deep learning, right? And mind you, people tend to assume that when we talk about machine, we talk about deep learning. No, we have other parts of machine learning. We have the decision tree. Some of you are familiar with random forests, SDG boost, SVM, support vector machine. These are other technique within machine learning, right? But the popular one everyone is familiar with is.
Sorry, is it design?
No.
It's not design.
Yeah. So the popular one is deep learning. I think I've already mentioned what deep learning is all about. So the deep learning is inspired by the neuron in the human brain, right? And okay, let me just talk about that. So it's inspired by the neuron in the human brain, right? I think I've already mentioned that the neurons are what did I say it is? Function approximator, universal function approximator. They can approximate a lot of any function, right? So thanks to deep learning, we can solve like a lot of problems, be it vision, be it audio, be it like different kind of problems. You can actually solve different kind of problems with deep learning. But then there are different parts of deep learning, depending on the kind of problem you want to solve. If you want to solve computer vision, stick with CNN, right? If you want to solve NLP tags, right? Natural language processing, stick with RNN and LSTM, right? Lately, a lot of things have been happening with Transformer. Transformer is like the bad boy of deep learning, like it's solving like a lot of problems. So be it visual, be it audio, like the GPT-3, GPT-4, the bar model are actually built on the backbone of Transformer model. It hasn't really evolved like that. What is happening lately is just the engineering has changed. So a lot of data, a lot of computes. Someone is asking the model how to fix projector, and it's giving you response. You understand? So that's what I've changed for the past couple of years: data and compute. But the model is still the same. So that takes us back to deep learning. So what you observe is that deep learning has like a size problem, right? Like when I mean size problem, see your GPT-3 has about 105 billion parameters, right? Your GPT-4 approximately 170 trillion parameters. Your PALM model that was released like, I think it was like 2 weeks ago, that's about that's less than 540 billion. And the sad thing about what is happening lately is that these companies, they don't release details about their model because it's looking like a trade secret, right? I can't even get the number of parameters for PALM2. This is PALM1 data. That's why I said less than, because what they just mentioned is that it is less than that of PALM1, right? So it's becoming like a big trade secret that, oh, you know what, you're not going to, they will always publish technical reports. But when you read their technical reports, apologies, just crap that is their technical reports, right? So imagine comparing your last model with your current model. And for someone that does not know about your last model, right? Even your last model, the technical report you wrote about your last model is not that. So it's like, I have a report though, this is it. If you're interested, read. Sad, right? And why it's looking like this? Because of what GPT-3 has done, right? When it came out, everyone stepped on it. Started looking like a AI warfare, right? And let me give credit to who credit is due. We all keep batching Facebook. Facebook out there is like one of the fully open source company. With respect to AI, Facebook will always open source their ML model. There's this very popular one called Llama model. They open source it. When they do something, they put it out there. Like, no matter how you hate Facebook, like the Facebook research, the fair or mail or whatever they call it, they open source their work. And I think people should learn from Facebook. Let's not talk about their data protection, their data. I'm talking about their AI. Like, they do awesome, their AI researchers, they do awesome job in open sourcing their work, right? So for this folks, for the remaining folks, I think they interviewed Sam Altman of OpenAI, asking me questions about the GPT-3 model, the size of the model. It could not even state it because it is a trade secret. So it's sad. I don't like what is happening because if I hide my stuff, you hide your stuff. Eventually, we all hide our stuff. You start acting, AI becomes a silo. We don't want things like that. So imagine the transformer model. They actually built this GPT for the T there in the GPT is actually transformer. Imagine Google did not open source it. We didn't have that product. So these are questions you need to start asking yourself, like, are these tools readily available for you to use? Like the only way you can interact with the ChatGPT is through their API. Yeah. So without that, is it free? You pay for it. Even the free one, sometimes it works, sometimes it doesn't work. So these are things that you need to actually look out for. But that simply means that deep learning, these models are too big for you to have around. They are too powerful for you to have access to, right? If you're going to have access to it, you have to pay. So the question is, how are we going to solve this problem? Right. And to be honest with you, this is personal. I don't think we should have like a big model that solves all problems. I don't like that idea. It sounds
like expert systems or just like AI in general.
Just AI, like building like the general, the AGI, like the so-called AGI. I don't really subscribe to that idea. I still believe that just like your wristwatch, it serves one purpose, tells time, right? The laptop, of course, is a general purpose mentioned, but you know what you do with it. Serves that purpose, right? So when you start having a superhuman system that does a lot of things, that's when we start assuming that you start attributing godlike properties to them. As somebody would say, and the ChatGPT sounds like a god. It is a god. Like these things are just functional approximator, right? They just that generative model. They are designed to predict the next word. That is what they are designed to do, right? But then with size, with engineering, they do well. They do well in terms of they can tell you, they can summarize tasks, they can come up with interesting things. But when it comes to, are they creative? I can't really comment on that. Sometimes they exhibit an element of creativity, right? They do exhibit an element of creativity. But then, I don't want to attribute that to them. I attribute that to us. We are creative because without our data, they are nowhere. So everything about them is just a reflection of who we are, right? So that goes back to what we are talking about. Deep learning has like a size problem. You don't have access to this model, right? So that leads us to the next thing. What can we do about that? So
the question cannot deny the fact that this AI is based on creativity, in the sense of generating different things that have never been created before. Yes, we know that if let's say we do give them our data, never be able to create something new and creative. So the only place I would say AI cannot do is basically not being able to like generate a new idea from nowhere, but generating ideas from what we have, and that's what most humans on the thing.
Yeah, our jobs are repetitive, right? Apologies, like we really do new stuff.
Yes.
I'm not hitting on anyone, like we really do new stuff. Whatever you're going to do next week, you've done like parts of it last week. We really do new stuff. So yeah, I agree with you. They are going to make our life better, right? But what still makes us human is that, oh, you know what? I want to build a product on this ChatGPT that will do something for me that has not been done before. That is the human part of it, you understand? So that is why you need to look into some of these tools. Don't focus on the technology, focus on the problem you want to solve with the technology, right? The moment you know the problem you want to solve, every other thing is just APIs and another level of abstraction, right? So that leads us to the next thought. We have already mentioned that deep learning has like a size problem, and first of all, that's the size of my old laptop. It has about 4 gig GPU dedicated memory, right? And this models, I don't even have access to them, but let's assume I want to train them. I want to fine tune them. I can't. For you to train, like I think the GPT-3 took about either 18 or $30 million to train in terms of the computational cost to train that model. And what that simply means that you need to like have like maybe A100s, about 3,000 or 4,000 A100 GPUs, right? You need to have space for the data, right? Then, of course, we're not even talking about the engineering, the human part of it, because whoever that is going to train this model, they are experts, right? They pay them well. So let's just focus on the computation. The computation cost about $30 million. That is a lot of money, right? So it has a size problem. And for you, the problems you want to solve are not that complicated. Let's be realistic. They're not really that. You don't need a GPT-like model to solve your problem. So that takes us to the next thing. Like we need to shift from this point of view, oh, this model is powerful, it's accurate, to models that are actually efficient, that can be deployed, that we can use to solve our problems, basically. So that leads us to the next part of the talk, which is edge AI. So you think what looking at the roadmap, talked about edge device, talked about AI, machine learning, right? Talked about edge computing. So the edge email looks like a combination of two things, right? It has to do with deploying machine learning model on edge devices. Can you guys see the roadmap?
Yes.
So that's basically what it is. So what we've seen so far is talking about different parts. So the question is, what is edge AI? So edge AI is the deployment of AI application in devices throughout the physical world. So it is called edge AI because AI computation is done near the user at the edge of the network. So rather than centralized cloud computing facility or private data. So what you observe is that we've talked about centralized system, the ChatGPT and code. These are all centralized systems. You need to access them using APIs, right? Now, the edge AI has to do with decentralized intelligence, right? Having model close to the source, having model close to the sensor, right? Then computation is being performed. So the very popular one I gave is your mobile phone. You have a model, you have a wake word model on your mobile phone that is being activated when you say that word hello Siri, right? It activates that wake word, right? With that wake word activates what? A service that is going to process everything that is being said after the wake word. You understand? So we have a model that is deployed on the device. And this has a lot of application. I think we talked about the autonomous vehicle. Most drones these days have like an element of edge compute intelligence, like they can identify people, they can keep track of people, right? Then some factories actually do have edge AI capability, whereby if someone should probably stop by like a robotic arm, close to the robotic arm, it deactivates itself, right? Like, oh, this is actually a person. I'm not going to operate till the person leaves, right? So the same thing with security and surveillance. There's some smart security or surveillance systems, right, that can keep track of, I think I will get to talk about that, I can keep track of people that are coming in, people that are leaving the facility. I can also keep track of weapon, keep track of fire incidents in a given location, right? So these are like things that you need to start thinking about. What kind of product or what kind of solution do I want to solve? So AI on the cloud versus AI at the edge. So we talked about machine learning, talked about AI. So now let's relate that to edge computing. So what we observe so far is that, and very popular one is ChatGPT. You train and you perform inference on cloud. That's what you do. It has been trained on cloud. The inference you are performing is when you type that prompt is being transmitted. A result is being generated. It's transmitted back to you, right? So that is AI process on cloud. Why we have AI process on cloud and on edge? So in this scenario, you've trained on cloud, right? Or your inference is done locally. Your inference is done on the device. So what you observe about this is that the issues of internet is not your problem. Why? Because you don't have to transmit your data out of the device. The only time you get to transmit your data out of the device if you want to train, and you don't train all the time. You can do inference all through the day. At night, you send your results to the server, right? So you can see there's a combination of both. You use one to train, you use one to perform inference. And there's some cases whereby you have on-device training, right? You can actually train on device. There are actually some cases whereby you can actually train on device. So why is AI moving to the edge? Basically, what is the benefit of edge AI? So one very popular one is bandwidth. I think bandwidth is the volume of data can transmit within a second, right? Do you have enough bandwidth to transmit data? You might be in a remote location, right? You don't have access to the internet, you're screwed. So you need that intelligence to be closer to the data source or to the physical source that you are interested in. Another very popular one is power. When you transmit data, it costs. The moment you put on your Wi-Fi, or the moment you put on your mobile data, your battery starts draining, right? You leave it on airplane mode, it can last you for like hours. But the moment you put on that button, put on that mobile data, starts sucking power, right? So that's power. Then the cost, the transmission cost, data cost associated with transmitting data. That's another thing you need to factor. Then latency, which is just the speed at which the data is being transmitted, right? You send data, you receive data. How long does it take you to receive that? Is it instantaneous, right? Or it's probably going to take like 2 seconds later, you get like a response. But if the model is closer to the physical system, you don't necessarily have to transmit that data, right? You have to just communicate with the model locally. So another thing is reliability. If there is no internet, your system is not working. Is it reliable? It's not reliable. So just like our beavers, right? I don't want to go political on the beavers, but at a particular point, I was kind of wondering that how come the beavers machine does not have like on-device kind of intelligence, right? Given that this, let's assume this is a polling unit, right? And assumption this is a polling unit. You know, we are expecting up to 50 people from this polling unit. There should be an element of intelligence that, okay, I am going to identify these people, right? I don't have to transmit that data out of the device, right? I don't necessarily have to do that. Like, I want to identify just these people, right? So these are like things that we need to start asking ourselves, like, can this be done, right? So these are like interesting things. And another very popular one is security, right? when you transmit data, a lot of things can actually happen. That moment that data is being transmitted out of the device, you can have like a man in the middle. Yeah, you can have like a man in the middle, like someone can just go in there, sniff your data. Then you might say, oh, it's just temperature data. It's not really that sensitive data, right? But then imagine you're transmitting a medical data, right? You're transmitting data from a power station, and someone can use that to like sabotage the power station, or transmitting data from a nuclear power plant. So these are things that you need to actually think about. So these are the benefits of having your model close to the source. So examples of edge application, you have like the logistic and cargo companies they use. I'm going to do like a demo for that. Then you have that for retail merchandise optimization, like having IP cameras in different parts of the retail store, right? And all it does is like keeps track of people. Besides keeping track of people, there are some areas within the retail store that people traffic a lot. Like they go there a lot. So imagine putting items that you want to like sell fast. Put those items there, okay, so your customers can actually see, right? And besides that, you can also use that to keep track of, okay, our customers bought items from this area. What are the items that are in this area? Why are they actually buying it? Maybe it's tissue paper, maybe it's hand sanitizer. You get what I'm saying? Yeah. So why are they actually buying that, right? So these are things that also another very popular one is traffic flow management, parking lots management. So this is let me just open this. So this is an interesting application of this connected internet. Okay, the interesting application of edge AI. Internet is really hard to know. So this is for aircraft logistics. So it keeps track of different parts of different components that are connected to the aircraft. And this is actually a very interesting application because I did my IT in Nigerian Air Force, the rotary wing there, the RG-204, rotary wing along Ikeja. And during that, during my IT, I learned a lot about aircraft. Most especially, there are different, when you're servicing an aircraft, besides even servicing an aircraft, when you're taxing an aircraft, right, you might leave different components within the parking space of the aircraft. And you will not know. You just assume, okay, because there's someone in charge of the ground power unit, they call it GPU, right? There's someone in charge of what was the other one? The stuff for putting up fire, the fire extinguisher. There's someone in charge of different stuff. So imagine assuming that, oh, this person is available, they know what they are supposed to do. Then the aircraft is about to leave. The GPU is still connected to it, or someone forgot the fire extinguisher, or someone forgot something. You understand? Because of the magnitude of the space, because of the space is actually keeping track of things, becomes a big problem. So having something like this that keeps track of different components, you can see that when the bridge is connected, it tells you that the bridge is connected. When you look down, you see the GPU. I think the GPU came up later. The GPU will eventually come up later. And towards the end. Maybe for another video. So So imagine that you have like a component that was supposed to be taken out, but was not taken out, and the aircraft lives like that. That aircraft is about 100 million or $20 million. That component is about $10,000. So a $10,000 would damage a $20 million. Doesn't make any sense. So imagine having like a system that keeps track of different components, right, and notifies the aircraft management, like, you know what, we forgot something, right? Before the aircraft leaves, please, I want to ensure that there is nothing connected to it, right? So you can, these are like edge-related products or applications that you can build. Hope this is clear. So let's go back to this. Then that takes us back to concepts in edge AI. So we talked about AI, talked about edge computing, right? When AI and edge computing mix together, we have edge AI, right? Then ML and edge AI, you have embedded ML. So when you go a bit lower, you have the tiny ML. I think I mentioned earlier that the tiny ML, that tiny ML space, we are referring to devices with a compute budget, with a power budget, not compute budget, with a power budget of about less than 1 milliwatts, right? Above that, you're in the embedded space, right? We have things like more than 1 milliwatts, right? The Jetson device, the Raspberry Pi, right? And another thing about the lower you go, the kind of language you are going to use varies. Like the lower you go, you tend to use language that are closer to the hardware, like C and C++, right? And the compute budget or the processing budget becomes smaller because they are assuming that we are solving a single domain problem. We're solving strictly computer vision, or you're solving strictly monitor gesture recognition, or like something specific. You're not changing the world. You're solving one problem. You're not expecting a GPT-like application on this level, right? You're solving a single domain problem. So the higher you go, you have more power to play around. Yeah, you can still use languages that are closer to the hardware, such as C and C++, but yeah, you can still do a lot of stuff with Python, right? I'm talking about the embedded ML. You can do a lot with Python, you can do with Golang, you can do a lot of stuff. So the higher you go, the more flexible, the flexibility you have, right? So these are things that you need to look out for. Do I have the technical skill to fit in to solve the problem below this stack, right? And that thing I always recommend is use what you have to solve the problem. Then once you solve the problem, you optimize later, right? You always optimize later. Oh, I want to do so and so. Then I've done that with Python, right? Of course, this is what it's going to cost me if I'm going to use Python. But now I want to do that with C and C++. I'm going to need a smaller device, and that device is going to cost me like $5 compared to something that will cost me like $100. But the fact that you solve that problem with the one of $100, coming down to $5 is just going to be like, do I need what are the parts in the $100 that I don't need? Right? You take those things out. This is what I need. This thing is $5. Right? Another question is scale. How many of those, like, are you going to sell 1 million of those devices? Are you going to sell 2,000 of those devices, right? If you don't have that scale problem, still maintain the higher level till you have the scale problem. Okay, I want to deploy to 10,000 locations. 10,000 by 200 is how much? 10 by 2 is 2 million, right? Compared to 10,000 to $5. You understand? So it's about scale. But then sometimes it's just about if you can solve the scale problem, it's fine. So that takes us to the next one, which is where we'll be operating, the level we'll be operating on the embedded ML level, right? We have the Jetson Nano, we have the Raspberry Pi. So for the Jetson Nano, the difference between the Jetson Nano and the Raspberry Pi is that the Jetson Nano has a GPU processor, right? And that's about 428 core Maxwell architecture GPU, right? And you can see that they have the same stuff in terms of communication, in terms of language. You can use any language on a Jetson Nano. It is a Linux machine, to be honest with you. It's just a specialized Linux machine, right? And this is the device for this class. Any question here? Okay. All my class is not boring. Okay.
What advantage do you have about this?
Yeah, so this is one. So with the GPU, you can process. There are some tasks that are GPU-like, or you can parallel processing. Like with GPU, you can process, like, especially something related to gaming, video, right? Machine learning also, you can process a lot of things using a GPU. It's a graphic processing unit. Its task is to process anything related to graphics, right? That does not have a GPU. There are some tasks that you can do them on CPU, but it's just going to take you like ages, right? Let me give you a very popular, not popular, a very personal experience. So the first model I trained was like TensorFlow 1, first version of TensorFlow. There's this very popular data set called Flower data set, Flower classification, right? That model took like 4 days. I was using HP something, HP 4530S Core i3, and that model took like 4 days. When it eventually finished training, I could not even believe it, because anytime I put on my laptop would be acting as if it wants to die. Written, the fan will keep blowing. I was like, I didn't want to stop. It was like, I've invested 4 days. What can possibly go wrong? You understand? And yes, you have to pause, you have to hibernate the system when your battery is about to run down, plug into power, continue training. I just wanted that process to just end. It's going to take you like 10 days. I'll wait. I just wanted to see the result. Yeah, when I saw the result, like, oh, awesome. Like, this is what it is. If I'm going to use a GPU, probably like 3 hours, it should be done with it. So that's like the advantage of using GPU. And this Jetson Nano has a GPU. And mind you, there are different kinds of GPU. There are GPU for, no, there are, to be honest, there are like training GPUs, there are for GPU for inference, right? Like, if you're going to train a chat GPT, you're not going to use the Jetson. So, but for inference, of course, you can do that.
What do you mean by inference? What's the difference?
Between training and inference. So, very popular one. When you interact with your chat GPT, right, what do? You send your prompt, right? That prompt that you are sending is the input to the model. The model will give you a result, right? That output. So that process of sending and receiving the output, that process is an inference. Why the training part is training the model with the data. Hope that's clear. That's actually a very important question. Like, when I keep mentioning terms that you're not familiar with, please just call me out and I'm going to look into it. Inference is clear, right? So that takes us, I think we talked about Raspberry Pi and Jetson Nano. So the next thing is the Jetson family, right? So what can be done? So the device for this class is the Jetson Nano. The power budget is about 5 to 10 watts, right? Then you have another one called the TX2. I think I demoed that. So this is probably exactly the TX1. But TX1 and TX2, they all look alike. You can pass this now around. So the chip, this stuff you're seeing here, is actually somewhere here. Yeah, that's it. So you can just pass it around. So this is a TX2. It's more powerful than the Nano, right? Then you have another one called Jetson AGX Xavier. So this is more powerful than both of them. So you use this for autonomous tasks, such as some element of self-driving, some element of all these robots that tends to like move around for inspection, use something like this. You can actually use the Nano for it. For most cases, they tend to use things like this. So what you observe is the higher the size, right, the more expensive it becomes, right? So, and that very interesting thing is they call it FT plug, T plug. So that's the number of that plug is what you use to measure the it's like the SI unit for graphics, right? How you measure the capability or the capacity of the graphics system, right? So TFLOP stands for trillion floating points per second. So the amount of floating point it can process under 1 second. So this one can process about 0.5. The Nano can process, the TX2 can process about 1.3. It can process about 10 flops per second. So, any question? So, I can't recall this. This is floating point 16. This is int 8. So they are different. Okay. Someone is going to give a talk on this. Somebody is going to give a talk on this, right? I have like a speaker that's going to give a talk on model compression. So there are different ways of, especially for inference, right? So you can compress the model. This is actually called a topic called model compression. So when you train models, we actually train models using FP floating point 32. That's how the computer represents your model. Of course, there's an element of sparsity, right? But then when you want to perform inference, what you can do is that you can compress the model, you can quantize the model, call it quantization. Instead of using floating point 32, you use int 8. So you are using less space. You're actually using less space. Instead of using 32, you're using int 8. And what with less space simply means it's faster, consumes less power, right? But then there's a trade-off. Less space means that the model accuracy might actually degrade, because usually as you are representing something with 32 space, now you're representing it with 8, you're going to lose some properties, right? So this is actually an area of research for folks that are interested in that. So you have like Jetson Nano. These are like, I think we've already talked about all this. For the Jetson Nano, we're going to talk about this in our in-person class. So this is why we use Jetson Nano. This is why we actually use the Jetson device. So when you compare the Jetson device to a Raspberry Pi, right, you can see that it's of no, it's not a, apparently this is not a apples to apples comparison, but Jetson wins in most cases, right? Actually wins in most cases. Thanks to what? Thanks to the GPU capacity or capability that is on Jetson. So this takes us to the stack, right? Where are we going to operate in? So the sad thing about, the sad and the good thing about, let me just stick with the sad part. Let me not criticize anybody. So we have the Nvidia device, right? And in Nvidia device, they have like different SDKs. They have like different SDKs, right? So you have like the deep stream. Deep stream is used for video analysis, like strictly not strictly video, both image and video. You have the tensor RT. This is related to what I mentioned earlier. This is actually where let's assume that there are some operations that are not optimized for the GPU. With tensor RT, you can convert your model to the format that is optimized for the GPU, right? Then you have the Jetpack. So the Jetpack is basically a Linux distro for Jetson device. A popular distro for Linux is Ubuntu, Fedora, Raspbian for Raspberry Pi. But Jetpack is Ubuntu for Jetson device, right? The reason why it's Ubuntu for Jetson device is because I have Ubuntu on this device. Like I have this Linux machine, I have Ubuntu on it, but I don't have Jetpack. Jetpack is for Jetson device, right? You understand? So Jetpack is an Ubuntu OS, but designed for Jetson. Just like Raspbian is, I think Raspbian is a Linux distro designed for Raspberry Pi. So you have inference, you have for training. So these are like the big GPUs. You can also use this for inference too. These are like the big GPUs. Tesla, the DGX GPUs for training. So resources and expectation. So we've round up, talked about edge computing, talked about talked about Jetson device. So for this workshop, what resource should we point to, and how can we manage our expectation? Like, what are we expecting at the end of this workshop? So for this workshop, the GitHub repo for this workshop is edge computing. I think the link is somewhere. It's on the slide here. See, this is the this is the GitHub repo for this workshop, right? And yeah, please ignore whatever is happening to this. My app. This is like the old stuff, right? It's unrefined. I'm still going to take it out. Just focus on week one, asset, and every other thing. But then this is what the workshop is going to. This is like the flow of the workshop. This is not really that way. But in general, you have introduction to edge computing. Edge compute, we've done that. So for this, we are going to do like setting up the Jetson Nano, right? Just going to do like a bit of an intro. Next week, we'll go focus more on that. So this is the resource you need for everything you need to know is on this slide. It's on this repo, right? Then which other thing? Okay, this is the link to the slide, right? So as we go along, I'll update the repo. So that's just that for the workshop, right? Then the next thing is for those that are interested in doing readings, right? It's actually a very wonderful book called AI at the Edge. You get to learn everything you need to know about building model on edge device, right? And the interesting thing about this book is that the way it was not written for expert. There are some books that you open like this. When you read the first chapter, if you even finish reading the first chapter, you will close it. But this book is actually a wonderful book, like for machine learning in general. Like I like when people write their book in such a way that it's relatable, right? Like I can read it end to end, even if I don't finish reading end to end. It sounds like story. Like I can read something, I'm like, okay, where am I going to apply this? Rather than I'll read it. And I'm not hating on books that are like they have like so much equation. Sometimes you see books with so much equations too, but the way the intention of the author you will know that through the way they write. There's some authors, when they write, like, they know that they're not writing for you, they're writing for another set of people, right? But this book is actually a wonderful book, right? You get to like learn like a lot of stuff, like inference, training, deployment, sampling, gathering data, everything you need to know to find it in this book. Then other materials, other things, there are other books, these are like other things that you can, if you're interested, like you have like a tiny ML, tiny machine learning. We have this book on signal, digital signal processing. Then also, yeah, I think I mentioned the tiny ML paper and project. So this is the project I started curating like 3 years ago when I wanted to understand what is happening in the tiny ML space, right? So here you find like a couple of resource, like in terms of research paper from 2016, where people have started like playing with small models, right? Till date. Like once in a while I get to like update some of the stuff, but why during my period or still in my period of curating this stuff, that's been a wonderful experience for me because I get to understand what is happening out there, like how people are using these models, right? How people are actually designing this model. And besides that, I get to see interesting applications, like the kind of applications people are building for tiny ML. That people are sorry using tiny ML, right? And these models are models that you can deploy on your laptop, you can deploy on your mobile phone, you can deploy on your wristwatch. These are like, okay, thank you very much. So these are like things that you can look out for. So you have like the paper section of it. You have like the course section of it. There are some courses that you can take. You have like the project section, right? Interesting project people have done. Then you have like the benchmarking. You have like the book section, just like the book I just mentioned, the AI at the edge. You have the machine learning on commodity tiny device. This is also another awesome book, Tiny ML Cookbook. So this is another interesting book like I would recommend for anyone that wants to go into this space. So these are just like tools, and also you have a section for tools and libraries and tools. So for this, we'll be using Edin course. So I'll get to talk about that later. And you have like courses. So if you have time, come visit this here. And don't forget to start the repo. It's about 400 and something. You can make it 500 before the end of the day. So let me sell my market now. Yeah, it's on the slide. So, this is the link to the book. If you want to buy the book, please buy. Put money in author's pockets. Buy. I'm not going to have this conversation with you. Next. How do I get? Click on this link here. So that takes us to the next thing. So this section is resource and expectation, right? So what are we expecting? So at the end of the workshop, you're expected to build like a image classification project on the Jetson, image regression project on the Jetson, right? You can have, if you want to have a look at what the project is going to look like, click on this link below. Like everything you need to know about.
In the TLI course, we use Jupyter Lab notebooks to build projects.
So
the high course, we put in line
this is what you
already got done.
So this is all you need to. This is all you need to know.
I'm gonna fix that.
This will eventually go through this. So that's like one thing you need to the projects you are going to build in this program, right? Then the second one is you get to deploy module on your mobile phone / laptop, right? And on Jetson device. So the reason why we want the mobile phone / laptop is because that is what you'll be going home with. For some of us that don't have a Jetson, what are we going to do about that? There's no Jetson for everyone, but there's a laptop for everyone. So you can. So the idea is that we want you to be familiar with building models and deploying models. And to be honest with you, like most models die on Jupyter notebook.
Why is that?
So it means that they don't get to be used.
Why is that?
Huh? Why? It's just, it's like, like they will, oh, we model, we train, but you never get to deploy. No one gets to use your model. So I think the moment your model is out, you've done a good job. Like that's it. The moment someone is using your model, I think you are a machine learning engineer. Yeah. But then till then, you're just a data scientist. Amazing. Yeah. GPU.
Yeah.
Okay. I'm going to talk about that. I'm going to talk about that later. But this class is focused more on deployment. So what I want is you train the GPU you are going to use is going to be on cloud using Edge Impulse. You train on cloud, but you now deploy locally on your mobile phone or on your laptop. All right, so this is the result for setting up Jetson, right? There's the YouTube, there's the link there, but then I'm going to walk you guys through how to do this like proper. So I'm just like showing you different stuff you need to know, just in case you want to, crash the program, right? That's it. Then at the end of the workshop, you're going to get a certificate. I'm not the one issuing the certificate, it's the Nvidia Deep Learning Institute who issue the certificates to you. And yes, the certificate. So folks that like certificate, yes, but then aside from this, it is my responsibility to also nurture Jetson ambassadors. So we want people to use this device, right? We want people to solve problems with this, right? And there are perks to the Jetson ambassador. That's actually like interesting perks to it, right? But besides the perks, like it simply means that someone wants to solve the, an edge compute problem. You're the go-to person. You understand? So this is what I am expecting, right? I expect you guys to of course, finish the program, finish the DLI program, right? But besides that, I expect you guys to think about problems in edge compute and solve problems in edge compute. At least attempt to solve problems in edge compute, right? And you can have a conversation with someone about this, like, oh, you know what? This is the problem I want to solve. I can do this using my laptop. I can do this using a Jetson. I can use it using a Raspberry Pi, right? And they were like, why do you want to use that kind of because it can actually do that. So that's I'm more or less like a mindset building, right? Like what kind of problems can you solve? Like pointing to that direction rather than shoving certificate. I know some people are interested in certificate. No arms, like it does the job sometimes, but beyond certificates, we want competency. That's it. But certificates are an evidence of competency, but not in all cases. Yeah. The question.
Other things like us, most of the people that's been here, just be playing them on
And on the Jetson.
yes. Why not taking home the jet?
You're not taking them because we don't have a one-to-one relationship with the Jetson.
Yes, so like
In the future, you can get a Jetson. Yes, I said in mail the acceptance form. Are you sure you are you
How
sure?
much is the investment? How much?
Okay, we'll talk about that at the end of it. Let me round this stuff up. So, setting up Jetson, I think that's what we'll do over there. We'll set up, we'll do this. Then training module, setting up Edipos account. So we'll also do this, but let me just talk about Edipos since they are one of the sponsors for this workshop. So Edipos is a platform for training and training, testing, and deploying machine learning models, right? Or the kind of machine learning models we are focused more on. We are not talking about like the big model, we are talking about model that can be deployed on device. It is initially when they started, it was more or less like, oh, this problem are actually easy problems. But with time, I got to realize that they are not actually easy problems. They're actually hard problems because what you observe about hardware vendors is that, oh, for the Arduino, they have their own workflow. For the Jetson, they have their own workflow. For NXP, they have their own, like, everyone is doing their thing in silo. And the machine learning space is not really like that. In machine learning, you have like two main deep learning framework. We have the PyTorch and the TensorFlow, right? And everything you're going to do, you are most likely going to use one of these. Also, we have other folks like the JAX and the MXNet and Co. But these are like the two. Like we have one that is research driven. We have one that is production driven, right? And what Edge Import has done lately so far is that it abstracted some of these things. Like, okay, we can import the model into the platform. It's going to quantize your model. It's going to give you a format of the model that you can deploy on any of those devices, you understand? So they made deploying model on edge devices, they've made it user-friendly, right? And, okay, we'll get to talk about this. So you can see the amount of projects. We have about 1,055,000 projects, ML projects that have been done since inception. We have about 20 million cloud jobs, right? So this is where the training part. I think someone asked me a question about training. So can train, they have about 20 million jobs, like models have been successfully trained on the platform. Then you have about data, you have about 238 million plus data samples, right? So it is actually a wonderful platform to use. Then couple of projects. So I've done like a couple of projects with Edge Import. So there's this tiny ML project I actually did, I think last year or so. So this has to do with deploying machine learning model on edge device to solve smart electric pro. You guys are familiar with these meters, right? So this is an edge device, this is an open-ended camera, right? So the thing here is that sometimes these meters are not smart. So we want to give them smart capabilities. Let's assume that you're about to run out, your unit is about to run out. How are you going to know? The only way for you to know is to probably go downstairs and go and check, right? But imagine having like a model deployed on this device, right, that keeps track of what is happening in the meter. If the unit is less than a given threshold, let's say less than 10 units, notify the user, right? So this has nothing to do with, you can see the interesting thing. You have like the computation and the communication. The computation is on device. The communication is, if something happens, if it is less than the given threshold, send that to the user. So imagine that this is strictly, this does not have the computational part. It's just transmitting. If there is no light, it becomes the problem. If there is no internet, it becomes the problem. So you see the importance of having your model on device. Your model is still intelligent. It only gets to transmit data when needed. You understand? So you can go through the projects. It's an interesting one. Like this is actually the step. Like actually went through the step. So there are other projects, predictive maintenance projects, other interesting projects. You can check them out here. Then that takes us to the any data, any device. So you can bring in your mobile phone, you can bring in any kind of sensor data, be it audio, be it vision, whatever it is, then any device. This is the Jetson Nano. This is the processor on Jetson Nano, right? Whatever device you can bring it in, you get the format that you want. So this is the workflow of Edge Impulse. You train, what do you select that from the data collection? So when you arrive at Edge Impulse, you collect your data, right? After collecting your data, you train the data, then you validate, then you deploy, right? So this is the workflow we will get to. Like this is a standard machine learning workflow, right? But yeah, that is in most cases, this is where the Jupyter notebook comes in. In most cases, some people's model dies in this part because they don't get to validate and they don't get to deploy. So they just do data collection, they train, and it lives on GitHub forever. It does not get to this point. So the point is, we don't want that. We want you to validate. We want you to also deploy. I'm listening.
Yeah, when you say validate, some people, like I would argue that I have my training, test, and validation set. So,
Are you validating it with the real world data?
it depends. It depends on my validation strategy. If I actually apply them.
Okay, I want to do inference, like live inference. I have like 10 customers. Can you do that?
No.
Okay.
Otherwise, I can deploy a Docker and push it guys.
I don't know if it was on my mind. You can't do that. Yeah, you should be in the cloud computing class. All right, I think that's all. So thank you. That's the end of this section. I think I'm actually let me go get food for this. So that's all. I think we can now move to the other side. But before we do that, any question? Any comments?
Yeah.
Any criticism?
Sorry,
What environment are you
I think you mentioned, that you mentioned that you don't get to talk about.
I don't get to talk about.
Arduino.
Yeah, I did talk about Arduino earlier. I think I did now. Yeah. So on this level, this is an Arduino BLE 3B. This is actually an Arduino BLE. You can see the so this is Arduino BLE. So that's like a flash memory of about 1 MB. The processor, you can see the processor is actually quite small. It's about 64. That one is 480. At this level, we have about 1.5 gigahertz. The other one is like 1.43 gigahertz. So you can see that the weights. Remember what we said about edge devices. The memory, storage, compute, and one other thing cannot be easily increased or decreased. Yeah. So once you exhausted the memory capacity, whatever budget you are switching to another device, right? If you cannot, your problem is not on this level, you go to this level. Your problem is not on this level, you go to cloud. Right, so yeah, any other question?
So do you have any special environments to run
Special environment. So Okay. Okay. So this is what it is. This is actually how it is going to be. So the workshop is going to be hands-on, right? Sad that we can't really have so much hands-on today, but the workshop is actually going to be hands-on. So that simply means once we come in here, we have like groups, right? Everything you are supposed to do during the week. And altogether, there are about like 6 videos. To be honest, altogether, like for you to finish this workshop, there are like 6 videos. Like, but then I don't really want you to focus more on those videos. I want you to also focus more on other things you can do outside the device, right? That's why I said that training on cloud and deploying on your mobile phone is one, right? Deploying on your laptop. Like I did a project, let me see, I did a project. I did a project with synthetic data last month or so.
What was the false data?
Synthetic data.
What do you mean?
So there's this tool called Nvidia Omniverse, right? So as we all know that data is like a big deal. If you're going to train a model, you need to use data. You need to have a lot of data, right? So now imagine that you don't have enough data. Right? What do? There are different things you can augment. The ones you have, you can augment, you can crop, create different instances of it, put them in a different environment and go. But another thing that we use this a lot in robotics is something called domain randomization. It generates synthetic data. So you can have like a 3D model of that object of interest. You will now put it in an environment. You change the environment, change the parameter of the environment. So you can see that the knife is changing in position. As it's changing position, you are generating data, you're taking pictures of the data, you're generating data. So with this, you can generate as many data as possible. So this is actually a part called domain randomization. So you have to like set this thing up on Nvidia Omniverse. So this model was imported, the table was imported, everything was imported. And of course, we write like this project was about 75 lines of code, like simple code, like almost like we walk you guys through the project to have like an idea of what's it. So this is what is happening. So as the knife is changing position, you're taking pictures of it. You're using this to generate data. So let's assume I want 1 million images of knife or something that's an object that is red. Just look at it from the point of an object that is red. You can do that with synthetic data, right? Then this is the data sets, like the breakdown of the data sets. Then this is how it looks like, the synthetic data that was generated, right? And here with Agent Force, I was able to train the model and deploy. This model was actually deployed on my laptop locally, right? So that's like why I said that it makes sense. This is something that you can do at home. You can do somewhere else, despite not having the Jetson, right? But then, and what we want to do is, let's assume you train all these things, done all these things at home. You now come to class and deploy the model on the Jetson too. So this is actually done with the laptop. So this is actually an interesting way. It has its own challenges, like generating synthetic data. But then at the end of the day, yeah, this was just the result. So, yeah. Any other question? Okay, in the absence of question, I think, so I need to we're going to have this class for 4 weeks. So we are going to have it for 3 weeks now. This is the first week. Then by the end of 4 weeks, we should be experts.
So funny.
Well, my own question, like maybe after today now, I will just get like some parts and I started to do it.
Yeah. I will probably. So if you want to enjoy this program, just make sure you are on Discord. Like that's my preferred medium of communication. I'm not a big chat person, but man, I'm an instructor, I have to communicate, so you're going to use Discord channel. Whatever I want, I'll probably communicate that with by Discord. Then also send mail. Sometimes another thing we do is like to do send mail. So like I think we all got the mail. So yeah. Any other question? Okay, in the absence of question, stop sharing. All right.